Welcome to Section 9, Lesson 4. A complex fraction is a fraction whose numerator or denominator, or both, contains other fractions. They look intimidating, but collapse to ordinary rational expressions in 3 steps once you know the technique. The key idea is the inner LCD. Look at every small fraction inside the complex fraction, find the least common denominator of those inner fractions, and call that the inner LCD. It is the same kind of LCD you computed in Lesson 3, just one level deeper. Multiply the outer numerator and outer denominator by the inner LCD. The little fractions inside both top and bottom clear to whole expressions, and the complex fraction becomes a single ordinary rational expression that you can simplify by factoring and cancelling. Today's 2 examples cover the standard 1-variable case and a 2-variable case. Both follow the same 3-step recipe: find inner LCD, multiply through, simplify. Take 1 over x plus 1, all divided by 1 minus 1 over x squared. The numerator and denominator each contain inner fractions, and the inner denominators are x and x squared. The inner LCD is x squared. Since x squared is divisible by both x and x squared, multiply the outer numerator and the outer denominator by x squared to clear all the inner fractions in one move. Top x squared times 1 over x equals x. X squared times 1 equals x squared. So the new numerator is x plus x squared. Bottoms x squared 1 equals x squared. X squared times 1 over x squared equals 1. So the new denominator is x squared minus 1. The complex fraction is now a clean rational expression, x plus x squared over x squared minus 1. Factor and cancel. The numerator x plus x squared equals x times x plus 1. The denominator x squared minus 1 equals x plus 1 times x minus 1. The factor x plus 1 cancels. The simplified result is x over x minus 1. Example 1. Simplify the complex fraction whose numerator is 1 over a minus 1 over b, and whose denominator is 1 over a b. The inner denominators are a b and a b. The LCD is a b, since a divides a b and b divides a b. So the inner LCD is just a b. Multiply outer numerator and denominator by a b. Top a b times 1 over a equals b. A b times 1 over b equals a. So the new numerator is b minus a. Bottom a b times 1 over a b equals 1. So the new denominator is 1. The complex fraction simplified to b minus a divided by 1. The result is just b minus a. A complex fraction with 3 nested fractions collapsed to a simple binomial. The inner LCD trick makes the procedure mechanical. Example 2. Simplify the complex fraction whose numerator is x minus 1 over x and whose denominator is 1 plus 1 over x. The inner denominator is x in both cases. The inner LCD is x. Multiply outer numerator and outer denominator by x. Top x times x equals x squared. X times 1 over x equals 1. So the new numerator is x squared minus 1. Bottom x times 1 equals x times 1 over x equals 1. So the new denominator is x plus 1. The fraction is now x squared minus 1 over x plus 1. Factor and cancel. The numerator x squared minus 1 is a difference of squares x plus 1 times x minus 1. The denominator is x plus 1. The factor x plus 1 cancels. The simplified answer is just x minus 1. 3 takeaways for complex fractions. They turn nested fraction problems into single-step computations. Find the inner LCD before doing anything else. Look at every fraction inside the complex fraction, list their denominators, and take their least common multiple. That single value is the lever for clearing the inner fractions in one move. Multiply the outer numerator and the outer denominator by the inner LCD. The inner fractions on top and bottom both clear because each one's denominator divides the inner LCD. What remains is a flat rational expression with no nested fractions. Factor the numerator and the denominator of the resulting rational expression, cancel any shared factors, and you have the simplified form. The same factoring techniques from sections 8 and the start of 9 handle this last step.